Hello everybody, this is the topic 5 video for chapter 5, compound inequalities. So we've been given inequalities and graphing them. Now we're adding the words and or. So what those mean as a basic descriptor is that if we see an and statement, we're looking for some type of overlap when we graph both of them on the same number line. If we see the or statement, we want a combination or to combine the two. So if we look at our first example, we have x is greater than -2 or x is less than or equal to 4. So if we see those two mini little number lines, we're going to use those. So we want -2 and 4 on both of them, and we'll graph the first one on the top. So x is greater than -2, and on the bottom x is less than or equal to -4. So because it's an or statement, we are going to have a combination of those solutions. So if we start at that furthest to the left, there's an arrow there, and then we trace along. When it stops at that 4, it picks back up on the top and goes forever. So if we were to find the solution, all the numbers are solutions. So that is going to be all real numbers, and graphically we represent that as just a line with an arrow on both sides, so that any number will satisfy those inequalities. If we take the same two inequalities, and I'm going to skip ahead because they're exactly the same, there's just the word and now, we are looking for the overlap of the two. So if we look, they both overlap from -2 to 4, so they're on top of each other, but anything left of -2 is only a solution for the bottom one, so it doesn't count, and to the right of 4 is only a solution for the top one. It has to be a solution for both, so we're looking for the overlap. So if we go to graph this, we have our points at -2 and 4. We take the endpoints from the graph, so there's an open circle at -2, a closed circle at 4, and the overlap is in between, so we connect them. And that is the final graph. If we look at our next slide, we've got x is greater than -5 or x is greater than +3. So we'll go ahead and make our two little mini graphs. We've got an open circle at -5 going to the right, and a open circle at +3 also going to the right. So because we have that word or, we are looking for wherever there's a solution. It doesn't have to be for both, just one or the other or both. So from left to right, we pick up at -5 and it drops down to the 3, and they both keep going forever. So when we go to graph, our starting point is going to be at -5 with that same endpoint, the open circle, but our graph just goes forever to the right. We don't need to pay attention to that +3 because it's a solution to the top one, so it doesn't matter that there is an open circle on the bottom. If we take the same two inequalities, they are still graphed the same on the mini ones, but this time we're looking for the overlap. So only when one line is on top of the other. So that is going to be starting at 3 going to the right. That little section from -5 to 3 does not count because it's not a line for both of them. So we start at +3 with the same open circle that we see and an arrow going to the right. Number 5, we've got x is less than or equal to -7, x is greater than or equal to 0. So we're going to use those values on our two number lines. Make sure we write them in order. We need a closed circle at -7 going to the left, and a closed circle at 0 going to the right. Now because it's an and statement, there's no overlap. There's nowhere on this graph that both of those lines are on top of each other, so this is no solution, just because of the word and. We're going to look at the or example on the next slide. But because there's no overlap, there's no solution because of the word and. So we've got the same two inequalities on our little mini graphs. This time we've got the word or. So it's wherever we see a solution. So left to right, it starts at like -infinity, stops at -7, but picks back up off at 0. So when we graph this with an or statement, it doesn't matter about overlap, it's just where's their solution at all. So we've got -7 and 0, a closed circle at -7, arrow going to the left, also an open circle at 0, and an arrow going to the right. So basically the only place there's no solution is in that little spot in between. So those are the only values that would not make those statements true. Number 7 and 8 are in a different format, but I like to think of them as sandwiches where we're saying x is in between -12 and 6. So when we see that, we'll plot those two points on our graph again, make sure they're in the correct order, and then take the inequality sign of the one closest to it. So the less than sign is closer to the -12, so we need an open circle there. And we've got a less than sign with the 6, so we need an open circle at 6. And since x is in between those two numbers, we draw a line connecting them. So anytime you see an inequality in this format, it's going to have a line segment look to it. So our next one, we've also have the sandwich idea because x is in between 3 and 8, so we need points at 3 and 8. And we need a closed circle at 3 because of the inequality closest to 3, and an open circle at 8 because of the inequality closest to the 8. Again, x is in between 3 and 8, so our line needs to connect 3 and 8. All those numbers on the line are considered solutions. Alright, you're going to do the U-tries on the next slide, and that concludes this video.